Next up, in Module 3, in Rational Expressions, we are dividing. In the last video, we looked at multiplying rational expressions, multiplying fractions. Now we are dividing fractions, dividing rational expressions. And you'll recall, or you may review, that dividing rational expressions, or just dividing fractions, is much the same with one extra step as multiplying fractions. To multiply fractions, then you can divide fractions, because division is multiplication by the reciprocal. Let's see what I mean there. Division is equal to multiplication by the reciprocal. What I've got here is the same first fraction, q squared minus 9 over q squared plus 6q plus 9. I changed division to multiplication, and I took the reciprocal of the second fraction. So that's how division by a fraction is defined. It's defined as multiplication by the reciprocal of that second fraction. That switches division to multiplication, and now we've already talked about multiplication, so we know how to do that. We know from the last lecture video that the way we multiply rational expressions, the simplest way to handle it is to factor everything that we can first. Here we've got q plus 3 times q minus 3, that difference of squares in the numerator of the first fraction. Q plus 3 times q plus 3 in the denominator of the first fraction. The second fraction is q plus 3 times q minus 1 in the numerator, and q minus 3 times q plus 1 in the denominator. Then we look for common factors that'll cancel. I see a q plus 3 and a q plus 3. Numerator and denominator of the first fraction, I see a q minus 3 in the numerator with a q minus 3 in the denominator. I see another q plus 3 with another q plus 3 factor in the numerator and denominator. And now we've got left just a q minus 1 in the numerator and a q plus 1 in the denominator. One more time here, and for all the marbles and all the tears of every student who has ever had to work with fractions, here we have a division of two fractions, and rational expressions no less, where all of the a values are greater than 1. So lots of AC method work to do here. Note that there is a typo here on this example. There should be, and there's a missing plus sign between the 3d squared and the 29d term. I apologize for that typo. Easy enough to fix. I'm fixing that now. And let's take this one step at a time, shall we? Dividing two fractions is multiplying by the reciprocal, first of all. Then multiplying two fractions, or rational expressions, is just multiplying straight across, which is easier to do if we factor and cancel common factors. I'm not going to explain every one of these AC methods nor show all of that work, but I'm giving the information that you need and you can verify for the AC methods here, like 18 in the numerator of the first fraction, a times c is 18 times negative 18, which I've factored a little differently. Instead of multiplying 18 times 18 to get some ungodly huge number and then finding a bunch of factors, what I've done instead is factored 18 and regrouped those factors into two numbers that work. I'm not going to explain this further in this video, but if you don't see, or if you have questions about how this is working on the right here, then please come to one of the live sessions and ask questions. I'd be happy to slow it down and go over the thought process here. But if you've already got a way that works, or if you already understand what I'm doing here, then I won't take up any more time on this video. And we'll say that 81 and -4 are two numbers that work and give us the positive 77 in the middle term there of that first polynomial, and we're good to go. But please ask if you need help with that. Similarly, here I've got 27 times 2 in the denominator of the first fraction, and then -9 times -6 are the two numbers that I've kind of recombined the factors to make work. In the numerator of the second fraction, 9 times 4 is 36, and -3 times -12 gives me 36, and also adds to -15. Finally, 3 times -44 in the denominator of that second fraction can be recombined as different factors to 33 times -4, and 33 and -4 gives me that positive 29 in the middle term that I'm looking for. Now I've got all the pairs of numbers that I need, and there. Feel free to pause the video and make sure that you see where all these numbers are coming from, but here are all 4 of the factorings that we need, all happening at the same time. Take a look at each one of them individually if you need to break it down a little easier for you. But here's all the information that you need, which then gets factored by grouping. So finish factoring by grouping there. And then we see what factors will cancel. And we find 9d minus 2 in both the numerator and denominator. We find 3d minus 4 in both the numerator and the denominator. We find 3d minus 1 in both the numerator and the denominator, so that 2d plus 9 over d plus 11 is the simplified form of this result.